Hello students, welcome to Lab 8. Today we're going to talk about pandas and all of the different ways that we can accomplish the same type of data manipulations that we've already learned about in R and gotten really good at. One thing to note before we get started is that in R and dplyr specifically, there's usually one way to do the thing that you want to do. For example, if you want to access some number of columns, you'd use the select function, and that's really about the only way that you can do it in dplyr. That's not necessarily the case with pandas. Often with Python, when it comes to data munging, there are 4 or 5 different ways to accomplish the same task. You'll see that when it comes to filtering rows. For example, we can filter rows kind of based on a logical comparison, or we can do it using the query method, or we can do it using integer location, or any number of ways. All of that being said is that I'm only showing you one way how to accomplish the task that we're really interested in doing. And these come down to the 5 core dplyr verbs: filter, select, mutate, group by, and summarize. I want you to keep your head in that space because I think that way of organizing data analytic tasks gives a lot of structure to the way that you think. When you become comfortable manipulating data in these 5 ways, you can really accomplish pretty much anything that you want. Adding other ways of accomplishing that may be better or worse in different circumstances, and I'm not claiming here in this lab that I'm teaching you the best way to do it every single way. What I am telling you is that by the end of this lab, hopefully, you should be able to reproduce everything that you do in R in Python. You may find it easier or more frustrating to do so using the Pandas package, but it is what it is. We're going to learn both programming languages, so may as well just jump in. So why don't we go ahead and open up a new file. We're going to do a Jupyter notebook, and we're going to import numpy as np. We're going to import pandas as pd, and we're going to say from plot9 import star. We're going to go ahead and run that, and I want to run that using Python. You'll notice it asked me, do you want to run it using Python or do you want to run it using R? Which brings up another little side digression here really quickly. If you want to, you can develop your R in an IPy notebook. IPy notebooks are language agnostic, so feel free to develop R in an IPy notebook if you want to. VS Code understands that and it's no problem at all. Let's go ahead and save this file in our lab 8. We're going to call this lab 8. We're going to save that, and I believe that kind of kills my kernel. Yep. So we're just going to run this again. And why don't I go ahead and comment this real quick. And the comment is going to be import libraries. Most of these comments I'm doing kind of for your edification rather than for example, this isn't necessarily how I would code when I'm at work, but it's helpful because you guys are relatively new to it. So when I share this lab with you, it's easy for you to see what you're doing if you don't quite understand what the code is doing. As you become more experienced, you don't want to not have comments. You definitely want to comment on what you're doing, but you won't need to be as explicit. Obviously, I'm calling a library here. I don't need to tell you that I'm importing a library. The next thing I want to do is I want to load my data. Now we're going to look at the diamonds data set, and we're going to read it using the read CSV function, and I believe I called it the diamonds data set. Yep, sure did. Looks like that read properly, so let's go ahead and take a look. Yep, and I got pretty much everything that I'm looking for. Why don't we go ahead and use the head method the same way that we could use the head function in R, and just take a look at the first 5 rows of the data set. Here's one thing. Remember, a method is basically just like a function that you can call on this specific object, but they're kind of built into this object type to make it easier for you to call them. So rather than saying head open parentheses data close parentheses, this is kind of like an and then, right? So we're going to say take a look at my data. Another method that we can use is called describe. And describe is going to give us a lot of summary statistics here about all of our different variables. So what's the price? You know, the highest price here, a huge diamond went for almost $19,000. The crappiest little diamond, I guess, went for $326. You know, the average is about $4,000. All this kind of information it'll give to you really quickly, and this is what we can use methods for. Terrific. So here we have our data frame and a handful of methods that you can use to very quickly get a sense of what your data looks like, what it is you're working with, and to just do a sniff check. Did it load properly? Yes, it looks like we didn't have any problems loading, so that's outstanding. Now let's talk about accessing elements in our data frame. Like an R data frame, a Pandas data frame is basically just a collection of NumPy arrays. Each column is a different NumPy array. Now, that might not be exactly technically 100% correct, but it's close enough for our purpose for you to understand what a Pandas data frame is doing. You'll remember from our last lab that we had to turn a list into a NumPy array to do element-wise arithmetic on it. We can do all sorts of different things on our different columns, and that's because Pandas treats each of our columns as its own NumPy array. So the question is then, how do we access different parts of our data frame? Let's say, for example, that I want to get a specific list of columns. Let's come back to the index here for a second. The easiest way to do that is to call your object, open up a square bracket, and say the name of the column that you're interested in. Now, two things printed out here. First, this second column right here will be very familiar to you relative to R, as if you did something like this. This is the output that you would expect, doing it the R way, right? Or, alternatively, you might write something like this, right? These are the same. These are the same things. However, you'll notice that we get something else. We get a second column here, and this is called the index. The index. One thing you'll note about our data frame, let's go ahead and print it out real quickly, is that you will always see this column called the index. The index is basically the name of a row. And when you first load in your data set, generally speaking, it will go from 0, Python is a 0 index language, to whatever the highest number of rows that you have. So you'll notice I have 53,940 rows, and my integer goes to 53,939 because I start at 0. The index, generally speaking, is important to keep track of in Python because for a lot of approaches, that's how Pandas selects or filters different rows. That's how it knows what row you're referring to. So when you shuffle around all of your elements, all of your rows in a data frame, it'll take its index with it. This wasn't really the case in R. We didn't spend any time thinking about what the index of a row is, what row number it was, although that information was there. When we rearranged our rows, we just expected that it would start counting from 1 at the first row and continue to go onwards. So keep the index in mind. Often when we do different types of operations on our data frame, they involve the index, and often we're going to need to reset the index so that it goes from 0 to its maximum value, as this is, rather than each row carrying its row label with it. So that's what the index is. When we do things that are index related, I'll be sure to call them out. So this is one way. Let's go back here. And actually, one method that we can use is index. Whoops. And it'll basically tell you about the index. Where does the index start? Where does it stop? and there's a step each one of the way. Sometimes that might be interesting to you, sometimes it might be not. Let's say an index is a row's name. Okie doke. Let's go back to data here real quick, and let's say I want to call more than one variable. I want to look at not just cut, but I also want to look at caret. All we need to do is we need to pass inside of these square brackets a list. So open up another set of square brackets that says cut and caret. Let me go ahead and comment this out here for a second so we can see what that does. Here we go. We got our index, we got cut, and we got caret. So accessing columns in our data frame. This is one way to do it. This is essentially equivalent to select. So that's what we did. We can take just a list of our columns and do that. Another way to do this is with the LOC function, lock. And what we're basically doing is giving the location of some rows and some columns. Lock is equivalent to the matrix notation that we used in R. So our equivalent is data row, comma, column. But here we're using the name of the rows and the columns. So let's go ahead and let's get rows 1 through 5, and let's get the cut, and let's see what we get. Notice that we got premium, good, and I'm guessing this would say very good if it printed out. We did not get the first observation, which was 0. We did not get 0. And we got cut, right? We got this variable. If we also wanted another column, you guessed it, we could do cut and we could do caret, and this is how we could get these things, right? So we could say accessing rows and columns through matrix notation. Use the lock method, LOC, for location. That's another way of doing the same thing. Let's say that I want to not just get the first 5 rows, or rather rows 2 through 6. Let's say I want all columns. In R, I might write something like this. I would say just comma and just give me cut. When I run that, it gives me an error because Python or Pandas doesn't accept blank row or column identifiers in lock. Instead, I want to use a colon, and a colon will say, give me everything. Give me all of the rows. So let's say I want, in fact, all of the columns, but I only want the first 5 rows or the first 3 rows. You'll notice, and I'm a little partial to 1-based indexing, because if you want the first 3 rows, you have to tell it to give you the rows at index 0, 1, and 2, which to my mind is a little bit counterintuitive, but so be it. So let's say the operator to return all of a certain type is the colon. So go ahead. So far we've seen how we might select certain columns. We've seen how we might select certain rows using lock, and now we've seen how we can select all of a certain type of rows or columns. The last thing that we can do, if we just want to look at certain types, if we just want to look at certain rows, we don't even have to use lock. We can just say, start from data, give me this many rows. This is probably the way that you'll use the least often, because most of the time you're not actually interested in taking a specific slice of a row where you know what the index or the integer is. But one benefit of doing it this way is that it goes from row index 1 to 4, apparently. Who knows? Who knows where 0 went? All this being said, This is another way of selecting rows. One you won't use very often, but it is out there. If you just want to take a look at some data, there's nothing wrong with doing it this way. Alrighty, so far we've kind of gone rapid fire through all of the different ways that you can pull data. So why don't we take a break here for a second, and why don't we, we may have used the diamonds data set in class before, we may not have. I'm not sure. Sometimes we use it, sometimes we don't. So why don't we stretch our muscles a little bit and get reacquainted with ggplot, this time in the form of plot9. One reason that we use plot9 and not other more, frankly, common plotting libraries like Seaborn or Plotly is that plot9 is basically just a Python implementation of ggplot. I've already talked about why I think ggplot is an outstanding visualization library, but for your sake, it is also helpful because it means you don't have to learn an additional plotting library. However, there are some quirks with the Python implementation of plot9 that we should keep track of. First off, we should always start by assigning our output to an object. It doesn't matter what you call that object. Let's plot the diamonds data set. And then we're going to open up parentheses. The parentheses tells Python that everything between these parentheses should be treated as one piece of code. Unfortunately, Python won't accept it if you don't put these parentheses in there, because as you'll remember, between different functions, we use the plus operator when we're making visualizations using ggplot. And anytime there's a line break, Python gets a little bit confused. There are other ways of solving this problem, but this is kind of the easiest way of solving this problem. So let's go ahead and create a data set. All I really want to know is how caret correlates with price. I'm guessing the higher the amount of carets, the more price. And I'm just going to use ggplot to do that. So this is a muscle we should be very familiar with. We're just going to start off with ggplot. But unlike R, where we have to say data equals such and such, it really demands that we just say data equals, or just data. Where does your data live? What's the name of the object? So we told it the name of the object. And now we're going to open our AES function. And we're going to say on the x-axis, I want you to put the caret variable. Notice that I had to put it in quotes. This is one of the things that is particular about Python that you didn't really have to think about in R. Anytime you reference a column in Python, in about 90% of the cases, you're going to have to enclose that column name in quotations. That wasn't really the case whenever we used the tidyverse. There are tools on the back end that helps R interpret when you're talking about a column, but that's not really the case here. So that's all right. All that really requires is for us to have an extra pair of quotes. And I know that on the y-axis, I'm interested in price. And sure enough, we're going to go to old reliable. We're going to use geom_point because I want to see a scatter plot. And then I'm going to say theme minimal. When I'm done with that, I'm going to take my object and I'm going to say g, which is the object name, dot show. This is a little bit of a big data set. There's about 60 something odd records, so it's going to take some time for it to plot. But sure enough, we get pretty much the exact same plot that we were expecting. Right? So essentially nothing has changed from the way that you're going to use ggplot, except that you need to put columns in quotes. And when you do thematic elements, for example, you're going to replace all of your periods with commas. So for example, let's say axis text. So let's say I want to increase the size of all my axis text. I'm going to say element text size equals 5. Note that in the R implementation, this function is called axis.text. But in Python, the period is a reserved character, And so we don't use periods in function arguments. So let's go ahead and run that and see what we get. It's teeny tiny. I guess 5 is a 5 is a small number. So why don't we go ahead and make it comically big so that we can give ourselves a laugh? Yes, outstanding. Wonderful. So I'm going to erase that because it's ugly and funny. But now that we've dived back into ggplot here for a second, hopefully you feel a little bit more comfortable knowing, hey, I don't have to relearn a new plotting package. I can just continue to use ggplot in the form of plot9, and all I really have to do is I have to put it in between parentheses. I have to quote any of my column names, and then I have to use g.show, or whatever your object name is, .show. Here, I think the benefits of a notebook are starting to become apparent. Your visualization is persistent in a way that it wasn't when we used RStudio. So for example, I'm going to upload these notebooks in the code section of the lab of the class. And what's great about this is that you don't really have to run it to see the results. I can just see that whoever wrote this, ran it, it seemed to work, and this is the output they got for each of these cells. That wasn't really the case in R. When I gave you some code in R, you had to run it yourself to see that it ran. And when it ran, its output was either put into the console for an ephemeral period of time or in the viewer pane, which only really lasted until you ran your next visualization. Okay, so we've done ggplot. I know we didn't have that planned, but that's okay. Alrighty, let's talk about how to filter rows, because at this point we just want to recreate the functionality that we had in R. We want to be able to do filter, select, mutate, group by, and summarize. So we're learning how to do those things in Python using Pandas. Let's say I only want rows where the cut is premium. What I can say is data, open square brackets. Anytime we're accessing anything in a data frame object, open square brackets. And now I want to reference the column that I want to make that comparison to. I'm going to say cut, and as in R, the logical comparison operator is double equals. I'm going to say premium. That's it. The R equivalent of this is to say, at least the way that I taught you, is data filter cut equals premium. When you're only doing one filter at a time, this is fine. This is fine. As you start to do more and more complex filters, which we'll get to in a second, this starts to get a little bit tedious. And remember, if you ever want to save any of your manipulations, all you have to do is just, put it back into an object like this. Now it'll be saved to the viz object, and we can continue our manipulations. We also may want to make multiple comparisons. How to do filters with multiple comparisons. So let's go ahead and just recreate the cut filter that we did. But I also want to, and pick color, which is equal to E. Now if I run this, we're going to run into a problem. And this error is not especially informative. It's not going to tell you what's going on. What we need to do is we need to wrap each of our individual comparisons in parentheses. Here's where the cumbersome nature of Pandas starts to become a little bit more obvious. Because all we would really do here in R is something like that. But the amount of code and referencing that we had to repeat using Pandas starts to become a little bit more apparent. That being said, for any of the purposes that you will use, this is pretty much fine. Another way of doing it is to use the query method. Although the query method is a little bit less intuitive. It needs to be wrapped in double parentheses, and then we can say cut equals premium and color equals E. And I'm sorry, we don't need to put that in, right? So just to kind of show you that this is accomplishing the same thing as that is, why don't I comment that out? And you can see when I run it, we're getting the same thing, right? These two things do the same thing. The problem with this is that it basically treats all of this as a string. And so unlike this version, which is highlighting different operators, highlighting different strings appropriate to their data type, query does not exactly do that, right? It's closer to this, but it's not quite that. So this is how to filter. So we've done selecting, we've done filtering. Let's do mutate. Let's take a look at our data set. And why don't we plot price? Because I bet price is very non-normally distributed. So we're going to open ggplot, and tell it where to find our data, and all I really care about is a price variable, and all I really want to see is a histogram. And the minimal theme is the best theme, I think. So let's just use that, and let's see what the distribution of price looks like here real quick. If it's normally distributed, a very nice bell curve, that's great. That makes all of our subsequent analysis much easier. But as you can see here, there's a lot of really cheap diamonds. And there's a handful of very expensive ones. So one of the things that we might do is we might log transform. Let's take a look at diamond prices. And why don't we comment on this real quick with the labs, and we can say the title is price of diamonds, and our subtitle might be lots of high priced diamonds, skewed data. Cool, right? So we're leaving a little commentary here for whoever comes after us so they kind of understand why we put this plot here. One of the things that we can do to squish this data together to make it a little more like a normal distribution, which are nicer to work with for a lot of reasons, is we might log transform, right? So let's go ahead and take our data in our price column, and if we wanted to log transform it, we might do something like this in R, the R equivalent, right? We might do something like start with data and then mutate, and then we'd say log price equals log base 10 of price. That's how we would accomplish that, right? We can't exactly do that. We can't exactly do that because we know that this is not exactly a function in Python that we can do. However, the NumPy library does allow us to do that. So why don't we take a look at data price, and let's see what we get. Sure enough, it log squished that for us. So we've accomplished this part of the mutate function. We've recreated that function. All we need to do now is to create a new column that contains that information. We need to assign this information back to a new column in data. So what we're going to do is we're going to do data. We're going to open up a column accessor, and in quotes, we're going to say log base 10 price, and I'm going to say equals, and then I'm going to run that, and then let's take a look at our data set. That's real freaking neato, right? So we have a new column that has done the manipulation that we wanted it to do, and we assigned that manipulation to a new column, and then we printed it out. How to make new columns. Notice that I basically treat a new column as a separate object. We're just assigning it. That's really all that it is. So there's nothing super cool here. So why don't we plot our transformed variable to see if it worked. We're going to go through the same old rigmarole, ggplot. Actually, why don't we be clever? Why don't we just copy paste this code? steal shamelessly from yourself. Don't rewrite code if you don't have to. Waste of your time. And then we just want to see what that looks like. Haha, this is much nicer. Now, log transformation often gives you multiple peaks like this. You may get censored or cut off here. That's just the nature of the data. But basically, our transformation has worked. This distribution is not the same on visual inspection as this distribution. So we're going to say log transformation fixed skewness. Cool. So we've done, and you can do any kind of operations here, right? Since these are NumPy arrays, you can do arithmetic operations like +1, -1, divided, whatever it is that you want to do. All right, let's go ahead and finish off by considering the summarize and the group by methods. Why don't we go ahead and talk about summarize first, and then we can do group by after that. So let's go ahead and take a look at our data again. We're already quite familiar with it at this point, but one of the things that we may want to do is to take summarize-like aggregations. We may want to know, for example, what the mean, median, mode, minimum, maximum, standard deviation, or any number of other kind of aggregating functions are of a specific column. So we already know how to call a specific column. We might say, let's take a numeric column for now. We might say price, and we're interested in looking at the median, right? That works, right? These are all functions, mean, median, sum, min, max, I believe. Yep, standard deviation is in there too. Wonderful. These are all methods that we can use on top of our data column, but that's not necessarily always useful, right? I want to do multiple aggregations of multiple different columns. So how do we, accomplish that? Well, we can do so by using the ag method. Let's say, for example, inside of my ag method, I want to open up a dictionary. And I'm going to say, what column do I want to do things to? Price. And what aggregation am I interested in? Let's just say the mean. So let's run that, and we get that, right? But like I said, sometimes I want to do more than one aggregation. I'm not only interested in the mean, I'm also interested in the median. So it'll say, here's your column. Here's the aggregation that we did. There are, of course, other aggregations that we can do. So why don't we make this a little bit easier to read and structure it as we did our dictionary from last time. And by the way, you can use any method that you can call on any of these functions here. You can also use any custom function you want, any custom aggregating function, although you'll have to define that as well. You can also use aggregation functions that you find in the NumPy package. So we have price, but we also have caret. Maybe I want to know what the smallest and the largest caret diamond is. And we get that right here. This is how we aggregate things. We can use the ag function. You can, of course, also use how to summarize columns. You can, of course, use the specific methods themselves, like min. So, for example, call a specific method on a specific column, or use ag and define what summarizations you want. The R equivalent of this would be something like data, summarize, and then price, min, mean equals mean price, etc. Right? Let me delete etc. so you don't think that it's a actual function there, or a argument, right? So this is kind of what that would look like. This is how we do it in R, or this is how we do it in Python using the ag function. So that's how you aggregate things. This is our recreation of this summarize function. We can either do it with methods directly on columns, or we can do it using the aggregation function. The last thing we may be interested in is our group by operator. So let's say I want to know what the minimum and maximum value, or what the minimum and maximum price is of a diamond in every cut type. So we can just use group by as we did in R. I'm going to say group by cut, and then I'm just going to do the same version. Actually, we can just pass a method real quick and it'll tell me. And in fact, min is a really interesting function because it'll work. You'll notice that I didn't specify any columns that I want it to do min on, so it did min on all of them. If I tried to do the mean on all of them, it would give me a problem. It has no idea how to take the mean of a character, but it can very easily take the minimum value of a letter, for example, right? So that's not exactly what I wanted. What I wanted was to take the minimum of the price variable. And there we have it, right? Alternatively, so we might say call a group by method, or alternatively, we can do data group by and do the same trick that we learned with ag. We can say price. I want to know the minimum price. Actually, I want to know a couple things. I want to know the minimum, I want to know the median, and I want to know the maximum. And I get all of those relatively quickly. So these are two ways that you can use the group by, which are really just an extension of the way that we were doing summaries before. How to summarize by group using ag. Cool. So in this notebook, let's summarize real quick, take it from the top, see what we got. We loaded our packages, we read in our data, we looked at a couple of different methods that we can use to inspect our data, in particularly head and describe, which should be generally familiar to you. Head is the same as it is in R, and describe is the summarize function. And we talked about a couple different ways that you can access columns. The first is just to use square brackets and then call the name of the column. Alternately, you can use the lock method to look at specific rows and specific column names. You can also just look at specific rows and call all of the column names with the colon operator. Another way to look at specific rows is just to call them by their index. And this is non-inclusive, by the way. Then we briefly took a detour to get familiar again with ggplot, and you notice that there were some differences, particularly that you need to quote your variable names in the plot9 implementation, but you don't have to do that in the R version, but otherwise they're basically the same. Then we got back to our data frames. We looked at one or two different ways that we could filter down rows. We looked at this kind of logical way of doing things, and we also looked at the query method. And we kind of went back and we looked at one of our variables to see what was wrong with it or what would make it difficult to work with. We realized it would be helpful if it wasn't so skewed. And so we applied a log transformation, log base 10 transformation to our price variable, and we assigned it back to a new column called log 10 price. And we plotted that, looked pretty good. And then we looked at different ways of doing aggregations. You can either call a method on a specific column, or you can use the ag method to specify what type of summarization you want to do to which column. And then the group by from there really is just the same as group by is in R, except for it's a method rather than a separate function that we use. So that's all we're going to cover for today. These are the basics of what you need to do in Pandas. As I mentioned before, in Pandas there's really 4 or 5 different ways of doing pretty much everything. You'll notice when we did filtering that I showed you 2 different ways of doing things. Which way is correct, which way is not correct, it's really up to you, to be honest. If you feel confident that you can write good logical comparisons without the assistance of VS Code, highlighting maybe where you forgot a quote, then use the query method. Methods also really lend themselves to the type of method chaining that we used in R that's similar to the pipe. But that being said, most people, I would say, code this way. So there's a couple of different ways to do everything in Python. How you use it and which version of the tool you end up using is really up to you, or frankly, whoever is reviewing your code, who will probably encourage you to code in one way or another. So now you have all the tools that you need to recreate most of the analysis that you can do in R, also in Python. Next week, we're going to start working on machine learning stuff. We're going to take a little bit of a detour in the first half of the week to talk about what the goals of machine learning are. And we're going to take a little bit of our time to slowly understand what it is we're doing when we're predicting things. And then later in the week, we're going to come back to Python relatively heavily, and we're going to start exploring the sklearn package, which is really the workhorse of how models are built in machine learning stuff. So great work this week. Look forward to seeing you next week.